Welcome. Here we're going to talk about solving percent problems. So the way we solve percent problems are actually the same way that we solve proportions. It's just kind of a special application of proportions. So let's talk about the generic form first of percent problems. So the generic form is going to be as follows. We will have some part divided by the base. This is the whole number or total number. And that is going to be equal to the rate, which is the percent, the actual percent number that you're given, divided by 100. So this is how we generic the generic form of percent problems. So let's consider an example. Find 8.5% of 160. So what we have to do in order to set the problem up is identify which is the part, which is the base, and then the rate. The 100 stays the same. So usually students will look at this and clearly see this is my only percent number. That is going to be the rate. So if I'm looking to set my proportion up, I know that I'm going to convert it into a decimal, 8.5 over 100 on the right-hand side of my equation. Now, the second part of this is, am I dealing this 160 number, is this giving me the part or the base? So the word of is a keyword that usually goes before the base or the total, the whole number, however you want to think of that. But that word of is going to be our big clue that 160 is actually the base number, the total whole number, however you want to kind of think of it, but base is the way a lot of textbooks call it, so that's what I choose to call it. And then I always have one unknown in my proportions. So if you have a situation where you write four numbers down, check again, because it's possible that you haven't actually understood the problem very well. You should have one unknown and only one. So maybe there's some weird word problems where something a little bit unusual is happening, or maybe it's like a true/false or kind of it's like kind of quote trick kind of question, but usually you're going to have just the one unknown, and then you have your other three components, and then we solve this the same way we always solve proportions. And remember that the way we solve proportions is we cross multiply. So x times 100 is 100x. 8.5 times 160 I should have done before, and I didn't. And it is 1,360. I apologize for that. And then I have to divide in order to solve for x. So I divide both sides by 100, and I end up with x equals 13.6. So we can also do a logic check on this problem. So when you're working with percents, it's often very useful to do this. A little mental math. 8.5, that's close to 10%. And 10% of 160 is 16. So I know that 8.5 is going to be a little less than 16, so I can logic check that number, 13.6, makes sense in the context of the problem. So that is how we solve percent problems. Thank you so much for watching.